Hello friends, welcome back. In this tutorial we will study about checksum. Checksum is an error detection method. How this method works, we will study about it. But first of all, we must know how we can add two binary numbers using one's complement arithmetic. Now let us see how we can add two binary numbers using one's complement arithmetic. So in this case, what happens whenever we have to add two binary numbers using one's complement arithmetic, we will add them. First of all, we will add them. Now, after addition, there are two cases. First case is that last column generates no carry. If the last column after addition it generates no carry, as in this case you can see here we have added these two binary numbers, and after addition this last column it has not generated any carry, then in this case what happens, whatever the sum is produced, whatever the result we get after addition, this is the result of addition using one's complement arithmetic. Now second case is that when we added two numbers, as you can see here, then what happens with this last column in addition, it generates this carry. So in this case what we will do, we will add this carry to the sum which was produced after addition, right? So whatever the sum was produced by the addition to that sum, we will add this carry, and after addition we will get the final result. So this final result is the result of addition using one's complement arithmetic. So in one's complement arithmetic, what happens if we add two n-bit numbers, right? Then the result will also be of n bits. As you can see here, using one's complement arithmetic, when we added these two numbers, the result is always of 3 bits, right? Here we added these two binary numbers of 3 bits, the result is of 3 bits. In case 1 also, when we added two binary numbers of 3 bits, the result is also of 3 bits. Now see how this checksum method works. In this method, what happens whenever the sender has to send a data unit, then at the center there is a checksum generator, right? And what this checksum generator does, it divides the data unit into equal segments of n bits, right? And after that, what happens, these segments are added together using one's complement arithmetic, right? Now when these n bit segments are added using one's complement arithmetic, then the whatever the total or sum is produced, that is also of n bits, right? Now what the sum is produced by the addition of these n bit segments, then this sum is complemented, right? And after complementing, whatever the number we get or whatever the result we get, that result is called checksum, right? And what we do, that checksum is appended at the end of a data unit which the sender has to send to the receiver, right? So it will be clear after this example. Now see there, suppose here there is a data unit of 16 bits and sender has to send this data unit to the receiver. Then what we have done, first we have divided it into two segments of 8 bits, right? Here you can see, and then we added it using one's complement arithmetic. So when we added it using one's complement arithmetic, then we get this sum. After that, what we will do the complement of this sum. So when we do the complement of this sum, then we will get this result, and this is the checksum. And this checksum will be appended at the end of this data unit, as you can see here. Now this extended data unit is sent to the receiver. Now see what the receiver does. Now at the receiver, the extended data unit is divided into sections of n bits each, right? At the receiver, the extended unit is divided into sections of n bits each, and then all sections are added using one's complement arithmetic to get the sum, and again the sum is complemented. Now after the complementing the sum, if the result is 0, then the data is accepted, otherwise the data is rejected, right? If after complementing the sum the result is 0, then it means that there is no error in the data unit, right? If the result is not 0, then it means there is some error in the data unit, therefore receiver will reject it. See here, this data unit was sent by the sender, right? As we see in previous example, this extended data unit was sent by the sender to the receiver. So receiver will again divide this data unit into the sections of 8 bits. because at the center we divided this data unit into the sections of 8 bits. So at the receiver also it will be divided into the sections of same number of bits. So we got 3 sections here, right? But at the sender, what happened? We had only 2 sections, right? At the sender we had only 2 sections. Why? Because at the sender we had only this data unit. At that time we did not have a checksum, right? Checksum was produced here, as you can see, and then it was appended at the end of data unit. So here in this case, at the receiver there will be 3 sections of 8 bits, right? Now they are added using ones complement arithmetic, right? Now after the addition, this is the result. Now this result, or we can say this sum, is complemented. Now after complementing the sum, we will get this result. This is simply 0. So since the result is 0, then the receiver will consider that there is no error in the data unit and receiver will accept the data unit.